Now today we will start with a new topic in engineering mechanics, that is truss and frame. And here we are interested in what are the different kinds of truss and frames and how we can analyze the truss and frame. So basically, first of all, I am starting with the definition of truss. Truss is nothing but a structural member used in forming structures. So a truss is nothing but a structural member used in forming structures, and also we can define the truss used for supporting the structures, and also we can define the truss used for transferring the forces. So basically we can define the truss in several ways. Truss is nothing but a structural member used in forming structures, or truss may be defined as the member which is used in supporting the structures, and truss may be defined as the structure used for transferring the forces. So here I am drawing a simple kind of truss here. Truss may be supported by simple support, and suppose the loads are acting here. Suppose it's a F1 Newton and F2 Newton. It's a typical example of a truss. So according to the rigidity, we can also classify truss into three categories: rigid truss, under rigid, truss, and over rigid truss. Over rigid truss. So how we are maintaining the rigidity? For maintaining the rigidity of truss, there should be a minimum number of members. Means there should be a sufficient number of members which provides the rigidity to truss. So we have a equation for rigid truss, that is nothing but m equals to twice j minus 3. Here m is the number of members and j means number of joints. So we can say that if m equals to twice j minus 3, then truss is called rigid truss or perfect truss. Similarly, if m is greater than twice j minus 3, means number of members in the truss is greater than twice j minus 3, then truss is called over rigid truss, or we can say that is called redundant truss or redundant truss. Here we are calling this truss is a over rigid because the rigidity of this truss when m is greater than twice j minus 3 will be more than the requirement. So that's why we are calling this truss is over rigid or redundant truss. If m is less than twice j minus 3, then truss is called under rigid truss, or we can say that deficient truss. Here we are calling this truss is under rigid because the rigidity of this truss is less than the requirement. So this kind of truss we can say that is under rigid truss, or we can also say that it is deficient truss because the sufficient member which is required to provide sufficient rigidity is less than the requirement. That's why m is less than twice j minus 3. So by this way we can say that if the truss is m equals to twice j minus 3, then it will be a perfect truss. Perfect truss means there will be a no deformation of the truss after removing of the load. That's called a perfect truss. In case of redundant truss, again there will be a no deformation of the truss after removal of the load. But here, with the help of extra member, we are providing the extra strength to the truss. So that's why we are calling it a redundant truss. In case of under-rigid truss or deficient truss, the number of members is less than twice j minus 3. It means after removal of the load, there will be permanent deformation of the truss. So for our practical application, we are looking for perfect truss, where there will be no deformation of the truss after removal of the load. So after removal the load, it will again gain the same shape and size. So we are interested in the perfect truss, and for perfect truss we will see how we can analyze. So now we will see that. So now start with analysis of truss. Analysis of truss, or we are interested in perfect truss, so I will say analysis of perfect truss. So in analysis, we are interested in forces in members. In analysis, we have to find forces in members of truss. So basically, there will be two kinds of forces in members of truss. It may be compressive force, or it may be tensile force. So basically, the analysis of perfect truss means we have to find out forces in members of truss, and basically the forces in the members of truss may be compressive force and tensile force. So our main objective is to find compressive or tensile force in the members of the truss, which is under the action of external loads. So for analysis, we are having two methods. One is graphical method, and second one is analytical method. In graphical method, as we earlier discussed, like with the help of graph, we can find out the unknowns. Here unknowns are forces in members. So by graphical method, we can find out the forces in the members. We have to use some scale, and with the help of graph, we can easily find out the magnitude of the forces. But the involvement of manual error will be more in case of graphical method, and result will vary from analyst to analyst. So this method is not be useful for get point of view. So I will consider, or I will more concentrate on the analytical method. So now consider analytical method. For analysis of truss, there are two kinds of analytical method. One is method of joint, and second one is method of section. So in case of method of joint, we can use two equation of equilibrium. In method of joint, the important point is we can use two equations of equilibrium that is algebraic summation of all the horizontal forces 0, algebraic summation of all the vertical forces should be 0. So we can only use these two equations of equilibrium in case of method of joint. Similarly, in case of method of section, we can use all three equations of equilibrium, that is algebraic summation of all horizontal forces should be 0, algebraic summation of all vertical forces should be 0, algebraic summation of moments of all the force for any point should be 0. So these three equations we can use in method of section. So in method of joint, what we are basically doing, we will see in method of joint. So first I am taking the method of joint. In method of joint, the first step, the step first, find reaction at the supports. Reactions at the supports. So method of joint, in the first step we have to find reaction at the support. Second step, identify the joint. Identify the joint where number of unknowns. Unknowns means forces in the members are 2 or less than 2. Step 3. Draw free body diagram of joint. Step 4. Find unknown forces in members by applying conditions of equilibrium. Step 5. Follow step 2 to step 4 protection. So by this way we can easily find out the values of unknown. So here there is one assumption we can make for solving the problems. Like we can say that let's assume all the forces in the members are tensile, and we have to proceed with the tensile force. And if our sign is coming positive, it means our assumed tensile force is correct. And if the sign is coming negative for the force, then our assumption is wrong. The correct direction will be opposite to the assumed direction. So the forces will be compressive. So it's just for our assumption. So basically in method of joint we have to follow the step first to step 5, and we can easily find out the unknown forces in. Now talk about method of section. Method of section. So step first in method of section is again same as method of joint. Find reactions at supports. Step 2. Cut a section which is passing through 3 or less than 3 members. That is step 2. Step 3. Draw free body diagram of smaller part. Step 4. Apply condition of equilibrium for finding unknown forces in members of truss. Members. So by this way we can find out the unknown forces in the member of truss with the help of method of section. So basically we are having two methods, method of joint and method of section. So when we have to use method of joint and method of section. So when we have to find forces in all the members of the truss, then only we have to use method of joint. So we can say that method of joint used when we have to find forces in all members of given truss. Similarly, method of section used when we have to find forces in a few members of given truss. So that is the basic difference between application of method of joint and method of section. And one more thing, in method of joint we can use only two equations of equilibrium. So at a time we can find out values of two unknowns. But in case of method of section we can use all the three equations of 2D equilibrium. So we can find value of three unknowns at a time. So these are the basic difference between the two methods. Now, for before going into the problems based on analysis of truss, we are having certain assumption for the analysis of truss. So assumptions in analysis of truss. So first assumption, the mass of each member of truss is negligible. Second, all joints are pin jointed. Third, all joints are frictionless. Four, loads are applied only on joints. Number 5, length of member is more in comparison with other dimension of member. That is, members of truss are slender. Slender means the cross-sectional dimension of the member is negligible in comparison to the length. These are the assumptions we are using for analysis of the truss.